Hello everyone and welcome back to another video. I have switched back to the smartphone as a camera once more because I want to compare some things, because the webcam might not be actually the best suited for these big picture recordings, and I might decide to just have the webcam as test bench view anyway. Here's that GTX 580. It has changed quite a lot. I have been very bored, which is why it has been designed like this. Anyway, this card, it's still the same date. This card came in today. It's a GTX 580 DirectCO2. It's the third DirectCO2 I have, and the first DirectCO2 that is dead. So the core on this is properly dead. The card does not initialize. You can put it in the system, you can try what you want. All the power rates fire up. All the voltages are correct. Physically the card seems completely fine, but the card just does not initialize. The PC will get stuck in boot. It will not post with the card installed, not even as a secondary. So this card is proper dead. Which is why I'm doing to this card what I was planning to do to that other DirectCO2 that did in fact work. I'm turning it into an e-power, and I've already made the first steps to that, as you can see here. So, yeah, the main purpose of why would I want an e-power like this? Well, I only have one really strong e-power, and that's the EVGA e-power 5, which is currently attached and will probably forever remain attached to my GTX 780 reference card, but that has a really good core. So that card has the ePower 5 and it will probably stay there, because I'm planning to do a lot of things with that card when I finish it eventually. And other than that, the only ePowers I have are made from reference GTX 580s and 480s, which do have a quite strong 6-phase for what it is, but you can't really e-power like a 780 or 780 Ti or just anything high-end with that. You can e-power like a 680, that's essentially like a mid-tier core, but you can't e-power something really high-end. You can e-power something really high-end with this. So this is an 8-phase VRM, a really powerful 8-phase VRM, since, I mean, it is powering a GTX 580, and this, actually the DirectCO2 was kinda known for being really successful. This card has been used for a lot of overclocking records back in the day. So this VRM can handle a lot, and I can confirm that firsthand because I have overclocked both my other 580s DirectCO2s that work, and the VRM just works. Yeah. So anyway, you can kind of see I've already made markings here. This is where I'm gonna cut the card because I want to keep the memory on, because this will be a dual output power card. As of right now, how the card is set up right now, all the power rails, that's core, memory, PAX, and 5 volts, do work without the PCI Express slot being used. Everything is running off of these two 12-volt PCI Express connectors. And that's thanks to these two buck converters on the back here. So, this is creating 5 volts, this one is creating 3.3 volts. And they're just using the 12-volt input capacitors here. They are leeching 12 volts off of that. And then they are outputting right here, which is going to the vCore controller. So it needs 5-volt VCC over here, and then 3.3 volts enable and power good. And then the card just fires right up. Oh, and yeah, you also need to unify the 12-volt power planes, of course, because your PCI Express slot's power has to come from something, and the memory on this card is, as far as I know, completely powered by PCI Express. I'm actually not too sure. Anyway, this and this blob you have to add manually. Now all the 12-volt power planes are unified. Like, you could theoretically just use one 6-pin, and it will fire up completely. I have actually done that. So yeah, the card is basically ready to be well chopped up, which I'm gonna do here. And then I will attach an volt mod to well, these two rails over here, because the rest of the card is going. And those volt mods will just be in the usual places. I've volt modded both of these rails on the other two cards already, so that's not really anything special. So yeah, I will have a very nice 8-phase V-core and a 2-phase memory just as an E-power. So yeah, that's kind of what the video is about, and I am going to demonstrate it. Why not right now? So I have a power supply here, and I will actually demonstrate that one 6-pin is enough for this. So let's take the power supply right here. I'm taking this one 6-pin, plugging that in. I'm just gonna show the back, because these, you will see these, if it's in the picture, you will see these line up, and I will hook up the multimeter to this. Voltage mode. I also have to do this to the, there we go. And when I turn this on, you will see that these turn on, and we measure our voltage, and we have V-core. And we have memory. And we even have let's take the ground over here. We even have our PEX rail. Wait, here. We even have our PEX rail, and of course also 5 volts, because that's still attached to the card. So the 5-volt buck converter on the back is kind of redundant, because this 5-volt buck converter still exists. But once I cut the card, this will obviously no longer be part of the card. And you can also actually check that we have 12 volts here, because if we go to 12 volt on the PCI Express slot, here we have 12 volts. What I do wonder is, yeah, we also have 3.3 volts over here, because of the 3.3 volt converter on the back. So we do not need, oh, this is getting really hot already. I need to turn this off. So you can see everything's working. So this will be a really nice E-power. Let's get this off again. And yeah, if you're wondering why, yeah, I was trying to kind of make it look like the EVGA E-power and the Kingpin cards. Like, I'm just gonna show the EVGA E-power. So I was kind of trying to get this style done with like the exposed copper by just using a gold marker. I was kind of going for this. So yeah. And then I also mark the inductors like the silver 1-sub memory, then the gold 1-sub V-core. And yeah. And yeah, I also, this is number 27. This is kind of interesting. So if you look at the serial number, yeah, this is number 27. By the way, the other two cards I have are number 92 and number 1412. So this is the lowest I got. Oh, by the way, yeah, I did that. I'm just not gonna mention it from now on. Yeah, so probably tomorrow I will cut the card over here. I will probably keep this triangle section on, because there might be internal traces there. And I do want to have the memory running, because I do want to use this on cards where I just replace like core and memory, so that I have both E-power, because you can totally just E-power core and then have the stock memory VRM, but that's kind of a hassle, and I think it's just a lot easier to just have it also E-powered. Because like, if you remember, like Buildzoid put the older EVGA E-power onto one of his GTX 480s, and that older E-power only has V-core, it doesn't have a VMem rail. So he had to use the onboard memory rail of the 480, and he had to like desolder certain transistors for the memory rail to fire up, because of course the core VRM is no longer there, so it doesn't get power good or something like that, and it gets pulled low. I just don't really want to deal with that. I just want to get rid of all the inductors and then solder on my own stuff. So yeah. And also with that said, I will probably sadly lose this part of the output filter because I need some place to solder my wires to. And for the memory, well, I could just do this. This actually is this. Now this might actually be ground. This might actually be ground back here. This big strip. Or is it? No, I don't think it is, because these capacitors, none of these are connected. Just the memory. Okay, this might actually just be memory. This entire big plane back here. So that will be easy. I'm just gonna scratch solder mask off here and then connect my memory there. And then core power, I will do this. Take the capacitor off, scratch the solder mask off, because this has a very nice like positive, negative, positive, negative, positive, negative pattern, which will make it really easy to connect things to it. And we will still have all the CAN type capacitors, plus whatever the card has on board of it. So that should still be enough. Yeah. And then also, I think I should have to thank Nachtfalke is the first person I need to thank, because he made a post on the HWBot forum about doing exactly this. Also had a dead direct CO2 card and also turned it into a dual output power board. From him is, from his post is where I knew how to connect these two yellow wires here. So this one is 5 volts and then this over here is 3.3 volts. Because the ASP whatever controller this is a rebranded UPI controller, I think, and even if you knew that UPI number, I don't think you would find a datasheet for it. So yeah, I was really dependent on someone figuring out the circuits here and just telling me where to solder things to. So yeah, thank you Nachtfalke for providing your HWBot forum thing. And then also, I don't know the name of the person, but there's also another, probably also on it from HWBot, someone who made also an e-power like this from this card on YouTube, who just also demonstrated the take the capacitors here off and then you have a really nice way to hook up your stuff. I could theoretically experiment with just using the keeping the capacitors and then soldering wires in between there, but that will be a bit more complicated. I will be forced to I will not be able to use as many cables, and that might limit my current capability, because I'm gonna be dropping a lot of voltage if I don't have enough connections. So I'll be figuring that out still, but yeah, first thing, I will have to cut the card. And then sand down the edges, so to remove any internal shorts that might have been created by the cutting procedure. I shouldn't really have to do anything to make it run again. It should just run even when it's cut. And then I need to volt mod it. The reason why I haven't volt modded it already is, at least on the reference 580 and 480, once you cut the card off, the resistance on the feedback pin changes. So you need a different size potentiometer. And, well, I have no reason to assume that this won't happen here. So I'm not gonna volt mod it before I cut it. I'm going to volt mod it after I cut it, in case the resistances from the feedback pin do change. And I need a different size potentiometer. So, yeah. So that's basically the state of the third direct CO2. So, yeah, that should basically be it. Just a kind of short video. I do kind of like how clean this one is. So, okay, this cable was to hold the converters down once the plastidip wasn't dry. Or while I was soldering and there wasn't any plastidip on it yet. I could remove this. I don't really feel like doing it. It's not really hurting anything. But yeah, I do like how cleanly I got this. So like the converters just take 12 volt and ground from the capacitor legs here, and then just one tiny bend around the front here to have the output. That's really, really nice, really, really clean. I like how I did this here. So yeah, and I hope this... I actually don't know what I'm gonna use this e-power for once it's done. I could use it for like I could, well, literally anything. Just can't really think. Well, maybe that 780 Ti reference card, which is gonna have the exact same problem as this, which is vCore VRM just not strong enough. Or who knows? Maybe like a 680 or 770 or something completely different. We'll see what I do with the power. But it's always nice to have one, because that also just like when you're troubleshooting something, it's always nice to have an e-power, because I had one spare e-power, but that had an issue. It developed like a sort of short circuit. Like even when it wasn't connected to anything, it had about 200 ohms from the output to ground, and it was always like instantly overheating because there was some internal short in it. So I scrapped that e-power. Actually, this converter is from that e-power. I salvaged it because this one... So I was originally planning to use this converter, which is why this says 3.3 volts on it. This was originally in here. But once I turned it on, this just died. It just suddenly died. Wouldn't put out 3.3 volts anymore. So I grabbed another buck converter that does work, put that in here, which is from the other e-power, because I do have more buck converters like this, but only the big kind that have like an integrated display, and they wouldn't fit on here. So I salvaged a small one from the other e-power. Anyway, that should really be it. How long's the video? 17 minutes, that's acceptable. So yeah, well, I'm probably gonna make another video once this is done. I just really like how this is coming along already, which is why I made this video. So, thank you all for watching, hope you enjoyed. Until next time, and goodbye. So, here's another extra part of the video. As you can see, the e-power is now more or less finished. There's still some finishing touches I need to do, like removing these capacitors to have proper connection points for my vCore side. For vMem, I already tried this. As you can see, I went a little bit too deep in this area. I tried to scrape off the solder mask with a Dremel. Unfortunately, I did go through the first layer here, but I still have quite some, quite a bit of connection area. I could also remove this capacitor to have some more connection area, and then just like go off these capacitors right here. The memory won't need that many connections anyway, but the core will need some, which I can get from here. And yeah, I mean, if you watched the GTX 680 WindForce repair video, you've already seen this in action. I've used this tiny red wire from the vCore section to use this as a means for voltage injection, which is how I found the short circuit on the GTX 680 WindForce. And yeah, so the power basically works now. I'm gonna demonstrate that. We're just gonna need a power supply right here. The cool thing is you don't even need to plug in everything. Like, I'm just gonna demonstrate. You just need one 6-pin and the thing will still work. So you see, these are running. We get 5 volts, 3.3 volts, and I will get my multimeter and show you that we actually have a voltage on the outputs. So if we now go here and measure the voltage across the output capacitors, here we have our vCore voltage, and here we have our memory voltage. So both outputs work, which is really, really nice. That's exactly what I wanted, because this is a very, very capable VRM. Let's just turn this off again. So yeah, this can e-power probably, like, this can e-power like a 780 Ti. Yeah. So basically this can e-power everything. So I no longer have to, like, I have the one e-power which I showed in previously. I have the EVGA e-power 5, which is the only other high current capability e-power that I have, which is on my really good reference 780, and I don't really plan taking it off there ever. So if I ever want to e-power another like high-end, high power consumption, high current draw card, I can now use this, and I'll even have both outputs for core and memory, which will be very nice. So of course I still need to volt mod these. I currently don't have voltage control on the outputs, but like that's trivial. I have volt modded 2 of these cards before, and even when it's an e-power, it's the exact same point where you volt mod them. Like, I mean, I could just show off one of them. So here's where you put the core volt mod. That is where you put the memory volt mod. There you can see, same card, just not painted like this one. Yeah. So I'm pretty proud of this one. Not just because it works, but also because I think it's really clean. Like, so the other e-powers I had, I don't really have one to show you right now. Well, actually I have one to show you right now. It's just attached to a card. You might remember this. This is the first ever e-power I ever made. So this is also from my GTX 580, but from a reference card. And it only has one output working. And I mean, it's fine for a card like this. This is a GTX 970, it doesn't draw that much current. But for like a 780 Ti, just like anything flagship that's not the 680 would probably also fine for this, but like Fermi cards, GK110 cards, just like your typical high power consumption graphics cards, using an e-power like this is probably not gonna be that great. And yeah, so this is the first ever e-power that I made, and also the first ever e-power job I ever made. And this, I mean, this works really well for what it is, but as you can see, this is kind of like, it has wires all over the place and doesn't generally look that great. So I really like how clean this is done. Like, it's done with just these 2 wires right here. One of them is, so this one, I think I've said that already. Like, this one's feeding 5 volt VCC to the controller. This one's feeding 3.3 volt enable to the controller. And it's just coming here from the back, and it's taking its 12, like these buck converters are taking their 12 volts off of the input capacitors right here, which is like covered in plastic, I don't know. It's really clean, there's like no wires. I mean, okay, the volt mods are gonna add some more wires, but yeah, this is like really, really nice. And it even needed one more, like this one doesn't need a 5 volt buck converter, it just needs 3.3 volts, because the 5 volt LDO is on the reference 580, it's like somewhere in this area, I think, so it's on the e-power when you cut it, whereas on the DirectCUI it's not. So that's why you need 2 buck converters for this one, instead of just one for a reference card. But yeah, this is a dual output, it is more phases, much more powerful phases. It's also gonna be, so if I remove these, you're gonna have a very nice like V-core, ground, V-core, ground, V-core, ground split, which is gonna be really, really nice for hooking things up. The reference 580 is also okay. You have like V-core here and then a strip of ground here. But you have to scrape the solder mask off, or just like don't do it like I did here and suffer the consequences. But here I just need to remove some capacitors. That's probably gonna be enough. So yeah. So the e-power works now. Really, really like how it turned out. And if you're wondering what the rest of the card looks like, it looks like this. So this is, and then I had this. So first I made like a cut like this, just to get this part of the card off, and then I did another cut like this, and then one like this, to get direct access to vCore without cutting off the memory controller part. And yeah, also an interesting thing, if you ever wondered what a GDDR5 memory module looks like on the inside, this is how. Yeah, so it has a silicon die, just like your typical GPUs, but covered in a bit of plastic, so you can see how it's like thinner than the others because I dremeled that off. But yeah, that's what memory modules look like on the inside, if you ever wondered. And yeah, this is now a donor for whatever components I need. There's a couple capacitors on here. Like if I ever get a card that has like broken bypass capacitors for PCIe, I can get them off of this card. Just generally multi-layer ceramics for memory cap modding. I don't know if I can salvage the protlyzer. Then also the memory modules might still be good on this, but that's gonna be a gamble because I never confirmed whether it's actually the core or just, well, the chance of all memory modules dying at the same time is pretty low, and the fact that the card didn't even initialize probably points at the core instead of the memory. But yeah, so I could try to risk a bit and salvage the memory modules of this for like future repairs. I can salvage this fuse, this slow dropout regulator, PEX regulator for when this might be compatible with the one on one of my GTX 680s that needs a new one of these. And yeah, I can make a keychain ornament out of the core, I guess. So yeah, yeah, that really now should be the end of the video. So yeah, ePower works really nicely done. Still need to volt mod it, of course, but that's gonna be a very easy step considering I've done it twice already. And yeah, I don't really know what I'm gonna use this on, but for when I ever want to ePower a card, I now have an ePower board to do it with. So yeah, thank you for watching, hope you enjoyed, and until next time, goodbye.